Hello and welcome to EC Electronics. So this video is a mock test on antenna subject. So it is a very important subject, especially for GATE and ISRO exams. So I try to include maximum numerical questions from the antenna from various areas. Okay, so there are 10 questions. Please try to attempt the questions if you are preparing for GATE exam or ISRO exams. And if you found the video useful, please don't forget to like, share and subscribe. Okay, so now let's see the 10 questions. So this video is a mock test of antenna subject. A lot of people do always ask me to do more and more videos on antenna and antenna theory and its numerical specifically. So in this video, I've tried to include more numerical questions. So this is a mock test of antenna. Okay, you can see the questions on board. Now let's see the solutions one by one. If the first question is, if directive gain of a half wave dipole is 2.64 and ohmic loss is 8 ohm, then determine its power gain. Okay, directive gain is given and ohmic loss is given as 8 ohm. Okay, so the loss resistance is given and also the directive gain is given. You need to find the power gain. So with the help of the equation for efficiency, you can find the relation between power gain and directive gain. But for answering that, we need, as I'll write the equation, efficiency is equal to power gain by directive gain. We have directive gain. We need to find power gain. But in order to find power gain, we need what is efficiency. Okay. Now, you can write efficiency in terms of the resistances, that efficiency is equal to radiation resistance by radiation resistance plus loss resistance. These two equations are very, very important while studying antenna and while doing its numericals. Okay, so you can find the efficiency from here, and this efficiency you can substitute here and find the power gain. That is our aim. Okay, so we'll try to solve this part, this equation. Now, if you look at this equation on this side, you need to find eta, right? You have the loss resistance. The ohmic losses is 8 ohm, means R loss or loss resistance is 8 ohm. Now, what is radiation resistance? That is a constant value for a half wave dipole antenna, which is 73 ohms. So while discussing or while studying various types of antennas and its characteristics, you should study these things also. Because in order to do the numerical questions, sometimes you should have to remember these constant values. Okay. So here the radiation resistance of a half wave dipole antenna is 73 ohm. So you can substitute this and this in this equation and you can find eta. Okay, so that is our aim. So I'm going to substitute values of radiation resistance and loss resistance, or the ohmic losses. In terms of ohms it is given. Okay, so I'm going to put it here, 73 by 73 plus 8, and while solving you will get the efficiency as 0.901. Okay, 0.901 is the efficiency. Now I'm going to substitute this efficiency here and I'll find the power gain. That is my idea. Okay. So from this equation, how will you write power gain? Power gain equal to eta into directive gain. Okay. Now what is eta? Eta we have found just now, 0.901 into directive gain is Already given in the question 2.64. Okay. So while multiplying, you'll be getting the gain as 2.37. But if you see the options, the values are given in dB. So you have to take the dB value of this 2.37. Okay. So I'm going to convert it to dB, just taking 10 log 10. Okay. So 10 log 10 of 2.37, and that will be equal to 3.74 dB is the answer for your power gain. Okay, power gain. This is your answer. So this is the answer for the antennas, half wave dipole antennas power gain. Okay, correct answer here is option B. Now I'll tell the quick way of doing these questions. See here, you can relate the efficiency with two equations. One is in terms of the gains, one is in terms of the resistances. So we have first taken the equation of resistance and found the efficiency, and we have substituted the efficiency value in the gain equation, and thus we have found what is the power gain. So what we have done here is, first we have to remember, or we have to study by heart, the radiation resistance of a half wave dipole antenna, which is 73 ohms. So you can use the equation, the efficiency, I'll write it here. The efficiency in terms of resistance is radiation resistance by radiation resistance plus loss resistance. So from here we'll find eta and we'll put it here and we'll find the power gain. I hope it is clear to everyone. Please note these two equations also. Okay. So first question, correct answer is option B. Now let's move on to the second question. Let me make some space for writing the second question so that it is visible to you. Okay. The antenna subject is very, very important, especially when you're going for GATE exams and ISRO exams specifically. Okay. Now, second question is from power of antennas. The power equation of antenna is very, very important. Okay. So the question is, transmitting and receiving antennas operating at 1.5 gigahertz with gains 25 dB and 30 dB respectively are separated by 1.5 kilometer. If the PT, that is the transmitted power, is 200 watts, then the maximum power that can be received at the receiver is dashed milliwatts. So all the terms are given to you. You need to find what is the received power. Now what is the equation for received power? PR is equal to PT into GT into GR into lambda by 4 pi R square. I'll explain each and every term. PR is the received power, PT is the transmitted power, GT is the transmitter antenna gain, GR is the receiver antenna gain. Now, lambda is the wavelength, R is the distance of separation. Now, while substituting these terms or these variables, you should know that the values which are given in dB, you should convert it back to ratio. Okay. So the gains, if you see the gains are given in dB. See, 25 dB and 30 dB, but you cannot substitute 25 and 30 dB directly into this equation because the equations are designed or derived by substituting the ratio gains. Okay. So this is one common mistake which students make while doing these type of question. So I'm going to convert the gain values from dB to ratio. Okay, so the gain of GT is given as 25 dB, right? And GR is given as 30 dB. I'm going to convert it back to ratio. That is 25 dB equal to 10 log 10 GT in ratio. GTR I'll write. So this is 10 log 10. So 10 I'll take and I'll divide by 25. I'll get 2.5. Taking the inverse logarithm, I'll get GTR equal to 10 raised to 2.5. This is the value we actually require. Okay. Only this value we can substitute here. So the value coming is 316.23 is the value for GT. I've just written R here just to make you know that it is a ratio value. You don't need to write it actually. Just this is GT. Okay, so this is the GT value. Similarly, you can find GR, convert dB back to ratio. So we'll do the same step. GR is equal to 10 log 10, the value which is given, the value we actually require. That is GR, again we'll write GR dot or GR R will write, okay. This value is given. What is the value? It is 30. 30 equal to 10 log 10 GR. So 3 equal to 10 log 10 GR, or GR value in ratio is equal to GR in ratio equal to 10 raised to 3 or 1000. So this is our GR value. We don't need to write this. Okay, it will sometimes confuse you. Okay, so this is the value for GT and GR we actually require. This is the gain of the transmitter antenna, and this is the gain of the receiver antenna, and in ratios. Earlier it was in, see here, it was in dB, but we cannot substitute that here. Okay, we have to substitute these values. Now, the next thing we need to find is lambda. You can see that here the value given is frequency. So frequency is equal to 1.5 gigahertz. So substitute for not to find lambda equal to C by F. Substitute C as 3 into 10 raised to 8 and F is 1.5. So lambda is 3 into 10 raised to 8. That is C by F, 1.5 into 10 raised to 9. Okay. So likewise you have to substitute, and you have to find the value of lambda. You can directly substitute it here in this equation and finally solve it. Okay. Anyway, while substituting these values, so these are the only values. Also PT is given. What is PT? PT equal to, PT is equal to 200 watts directly given, right? So no other things to worry. All the values are now in our hand. We have lambda, we have GT, we have GR, we have PT. So just substitute and find. The value we'll be getting is, I'll remove it. The value of PR obtaining is 7.12 milliwatts. Okay. Correct answer is option A. Second question, correct answer is option A. So if you have GT, if you have GR, if you have PT and lambda, and R is also directly given. Okay, it is 1.5 kilometers. So you have to convert it to meters. 1.5 into 10 raised to 3. Okay, so all the values are now given, and you have to just substitute in the equation and find PR. PR equal to 7.12 milliwatts. Okay, correct answer is option A. Now moving on to the third question. Third question is a little bit simple question. If you know the equation, you can solve it. Third question. An antenna has a single main lobe pointing in the Y direction. The half power beam width in Z and X direction are 30 degree and 30 degree. The approximate directivity of antenna is dash. So this equation we have discussed while doing the formula revision of antenna. We have done a formula revision of antenna, that is in the formula revision playlist and also in the antenna playlist. Okay. So how to find directivity in terms of the beam width? Directivity D equal to 41,000 by theta 1 theta 2 degree. Okay. So here we need to find the directivity of the lobe pointing in the Y direction, and the angles has to be perpendicular to this. Okay. X and Z. Sorry, Z and X. So it is Z and X. So here you have to substitute the values directly. It is in degree. Okay. Also in question you have given the beam width in degrees. So 30 degree, 30 degree. Just take the product and divide. You will be getting directivity D equal to 45.56. This will be the value you will be obtaining. But if you see the options, it is given in dB. Okay. So you have to convert it to dB. Just take 10 log 10. 10 log 10 of 45.56. It is 16.6 dB approximately. Okay, correct answer is option C. So in antennas, a lot of times the value you'll be getting won't be the final result, because sometimes the options will be in dB, or sometimes you have to convert dB back to the ratio. Okay, so this thing is very common in antenna subject. You have to take care of this thing while doing the numericals. Okay, so the third question, correct answer is option C. Moving on to the fourth question. An antenna has a radiation resistance of 50 ohm and a loss resistance of 10 ohm. If the power gain of the antenna is 20, then the directive gain is dash. Okay, so this is again a connected question to the first question which we have done. If you have understood the first question, by this time you can do this fourth question. Okay, now I'm going to solve it. First, I'll be taking the equation in terms of resistance, then I'll be taking the equation in terms of gain, and then I'll be finding the directive gain. In the first question we had to find the power gain. Here we have to find the directive gain, only that is the difference. So eta equal to radiation resistance by radiation resistance plus loss resistance. Also eta equal to power gain by directive gain. So you have to link these two equations. Okay, so the radiation resistance is 50, so 50 by 50 plus what is loss resistance, it is 10. So 50 by 50 plus 10, that is equal to 5 by 6. Okay, very simple. 50 by 60, you'll be getting 5 by 6 as eta. Substitute this eta here. Okay, eta is 5 by 6. Now what is the power gain? Power gain is 20. Now what is directive gain? Directive gain is 20 by 5 by 6 or 20 into 6 by 5. Value you will be getting is 24. Okay, so 24 is the answer, and the correct option is option A. Okay, so here if you see, the values are not given in dB. You can see in the question clearly that if the power gain of the antenna is 20, it is not given that it is 20 dB. So if it was 20 dB, you again have to convert dB back to ratio. So always remember this 10 log 10 and taking of inverse of 10 log 10. Okay, dB to ratio and ratio to dB conversion is very important. So the fourth question, correct answer is option A. Okay, moving on to the fifth question. Fifth question, the basic equation of radiation that is applied to any antenna irrespective of type of antenna is dash. A, IL equal to QV, B, IQ equal to LV, C, I by L equal to Q by V, D, none. So the answer is IL equal to QV is a common equation for all antennas, where I is the current, L is the length of the current element, Q is the charge, and V is the acceleration of charge. Okay, so we know that in antennas there are current carrying elements or current elements. So this is a equation connecting the charge, the current, the length of the current element, and also the speed of the charge carriers. Okay, so IL equal to QV is the antenna equation. Correct answer is option A. Sixth question, again a theory question. The impedance at the center of antenna is known as dash. A, parasitic impedance, B, radiation impedance, C, transmission impedance, D, recovery resistance. So correct answer is option B, radiation resistance. Okay, the impedance at the center of antenna is known as radiation resistance, which is option B. The seventh question is, if the power input to an antenna is 100 milliwatt and the radiated power is measured to be 90 milliwatt, then the efficiency of the antenna is dash. A, 75%, B, 80%, C, 90%, D, insufficient data. So the correct answer is 90%. So the ratio of efficiency eta equal to the radiated power, the ratio of the radiated power to the incident power. Radiated power to incident power. This is the simple equation. So till now we have discussed all the other equations. The equation in terms of gain also we have discussed. The equation in terms of the resistance we have discussed. This is nothing but the equation in terms of the power, radiated power to input power. That is eta, and the answer coming will be 90 by 100, or it is 90%. In percentage if you write, it is 90%. Correct answer is option C. The 8th question, a theory question it is. So I've tried to include maximum variety of questions. Okay. So the most important equations are the equations of directivity, the equation of received power, and all the gain equations. 8th question. At what distance from antenna does the far field start? So there is near field and far field for antenna. What is the distance at which the far field starts? A 2 wavelength, B 5 wavelength, C 10 wavelength, D 25 wavelength. Correct answer is option C. At distance from 10 wavelength or 10 lambda, the far field distance of antenna start. Okay, correct answer is option C. So if you want me to do a video on near field and far field of antenna, how these things are calculated, please do mention in the comment section. We'll be doing that. Okay. So here correct answer is option C. Now, 9th question. The type of dipole antenna that has highest bandwidth is called dash. A. Conical antenna, B. Yagi antenna, C. Helical, D. Macaroni antenna. Correct answer is option A. Conical antenna it is a type of dipole antenna which is having the maximum bandwidth, and the length is 0.73 lambda. Maximum bandwidth it is having, and it is having a length of 0.73 lambda. Okay, correct answer is option A. 10th question. A transmitter feeds a half-wave dipole antenna with 100 watts power. That is, a transmitted power is 100 watts. Calculate EIRP. So about this EIRP we have discussed in the antenna formula revision video. So EIRP, effective isotropic radiated power, it is actually a link budget, or it is an antenna budget. It is actually taking care of all the power gains and power losses, and it is taking the sum total of the power. That is, it will be taking all the sums or the gains and the powers, and it will reduce all the losses from it. So it is a power budget. Okay. Now, in order to calculate EIRP, we can use the equation PT into GT. This is a very simple equation, but when the losses and other things are given, you have to include that also. That is, the power and the gain, then minus losses. Okay. Likewise, the equation will come. EIRP equal to PT into GT. Here, losses has not been mentioned, so you can directly use this equation. Now, what is GT? It is not given in the question, right? But the question is again regarding a half-wave dipole antenna, and GT you should be knowing it is 1.64, a constant value. So substitute GT here and you will be getting EIRP. So EIRP equal to PT is 100 into 1.64, which is 164 watts. Okay, so correct answer here is option A. 164 watts is the value for EIRP. Okay. So these are the 10 questions which I have included in this video. I really hope that you found the video useful. Again, you cannot find a lot of questions on antenna, especially the numericals over YouTube. So if you're preparing for any competitive examination, especially ISRO exams, this video is very helpful. So please do share it with those kind of friends. And if you found it useful, please do give it a thumbs up. And if you want more videos, please do subscribe to the channel. Thanks for watching and keep on watching.